Welcome back. Today we are starting our unit on equations. This video is solving 1 and 2-step equations. The essential question, how can you use inverse or opposite operations to solve an equation?
So in your notes, the first thing we want you to do is fill in our 3 steps, and you're going to kind of hear these over and over as we work our way through it. First one is anything you do to one side of the equation, you must do to the other. It has to stay balanced or equal. So you're going to notice that in a lot of these problems, we're going to draw a line down through the equal sign, and you're going to have to do your work on both sides of that line. Step 2 is to solve any equation, you must undo whatever was done to the variable by using inverse or the opposite operations. So think of if they added, I want to subtract, or if they divided, I want to multiply. I want to do the opposite. Step 3 is you must show all of your work and you must check your solution. The check's going to be pretty basic for these first couple, but as we get to more complicated equations, it's going to become more and more important to make sure we're checking to make sure we really did get the right answer for us.
I know there's a lot of words for those steps, but get them down before you press play and continue.
Nope. I'm getting careless with my lines.
All right, example 1. W plus 8 is equal to 13. Mentally, it's asking us what number plus 8 is equal to 13, but we're working with algebra, so we're going to actually start using our steps. The opposite of adding 8 would be subtracting 8 from both sides. So you are physically going to draw the line and show subtracting 8 from both sides. I know this seems kind of silly, a waste of time, but you just go with it. As we add steps, it'll become more important in what you're doing.
So we were adding 8. Mrs. King had us do the opposite with subtracting 8. So like 8 minus 8 turns into a 0. So that drops out, and we're just left with our variable of W. 13 minus 8 is 5.
Okay, example 2.
Check.
Oh, sorry.
To do your check, remember you're going to plug your answer back in place of the variable. So instead of W, I'm going to put in 5. 5 plus 8. Well, 5 plus 8 is 13. That's what I wanted to get for an answer. So I have checked my solution.
The left side balance the right side. 4x is equal to negative 8, so that's 4 times a quantity. So to undo the multiplication, we are going to divide both sides by 4. So we're going to physically show the dividing both sides by 4. 4 divided by 4 is going to give us a 1x on the left, which is what we want. We want the variable alone. We want it to be 1x. And a negative 8 divided by 4 is going to give us a negative 2. It's kind of important to check right now not only the computation, but our signs. So we're putting the negative 2 back into 4. So 4 times the negative 2, 1 negative, when we're multiplying, will give us a negative 8. So don't just go through the motions of that check. Check your signs. Make sure you have a negative when you need one.
All right, so we're going to do a couple more. We've got a note up here. Watch your negatives in your subtraction. That's the biggest places where you're going to make your mistakes. And then don't forget to do your check. So we always start by drawing a line down through the middle, and then I always ask myself, what did they do to the variable? That's always your focus. It's not the left side, it's not the right side, it's the variable that decides your decisions. Negative 6m means negative 6 times m, so I want to do the opposite, or the inverse, which is to divide. Feel free to use your little division symbol if that makes sense for you. A lot of times we'll use a fraction bar, and that's another way of showing dividing. But I'm going to do that same thing on both sides. I'm keeping it balanced. Negative 6 divided by negative 6 is a 1, so I'm left with just 1m or m. Negative 42 divided by negative 6. Negative divided by a negative is a positive. 42 divided by 6 is 7.
Time to check. Putting m for 7.
Oh, not 3, 7.
Negative 6 times 7, 1 negative times a positive is going to give us a negative 42. So the left side does check with the right side.
And we know these early checks are simple, but you do want to get in the habit of doing that. It'll catch those little mistakes, but it'll also keep you in the habit of doing it for when we get to the more complicated problems.
All right, this time the variable is on the right-hand side. When we read the equation to start, it says y minus 6 is equal to negative 9. So we need to undo the subtraction with addition. So we're going to add 6 to both sides. So a negative 6 and a positive 6 make your 0 pairs. So we're left with a y on the right side. And a negative 9 plus 6, different signs, subtract, keep the sign with, so we need that negative 3 for our answer. Our check becomes super important with the negatives. -3 minus 6 is the same thing as -3 plus the -6. Same signs, add them up, does give us a -9.
Oh.
So it's a good idea to check those negatives
Oh, sorry, I lost my pen there.
when you are checking your work. That's what I was going to say.
All right.
Explain your fancy star.
All right, for this one, there are two reasons that we have a little star here. One is because the variable part isn't first, it's the 7, and it's also because of this negative over here and what's going to happen next. So always focus on the variable. What did they do to x? Well, they added 7, so we want to do the opposite. We want to subtract 7. If you've noticed, every time we're doing a step, our goal is to get the variable all by itself. We're trying to isolate the variable so we can know what it's equal to. So they added, so we subtract. 7 minus 7 is 0, so I'm just left with x. But here's where you're going to make a lot of mistakes if you're not careful. Subtraction and negatives don't go along with each other very well. It's very easy to mess this part up. So anytime the number up top's a negative and you're subtracting something from it, I want you to immediately change it to adding the opposite. That way you know, oh yeah, I'm really adding two negatives together, so I know I'm going to add them and keep the sign and get my answer of -15. Up here, it was a regular subtraction. We were okay just doing the opposite. But down here, that subtracting and a negative just do not get along well. So we definitely want to change that to adding the opposite.
You got to check.
All right, so now I plug in my x of -15. 7 plus -15, different signs, subtract. 15 minus 7 is 8, and we take the sign of the bigger number, so it's going to be -8. And that's exactly what we wanted to get up here.
Our last example, a lot of kids just stop. They don't know why there's a fraction. We need to read it out loud. When you get stuck, ask yourself what operation is happening with the z. So that's z divided by 3 in fraction form. The fraction is taking the division operation. So to undo division, we need to multiply both sides by 3.
So that fraction mark is just kind of code for dividing.
So 1/3 times 3 over 1 is going to give me a z. Z is now by itself, and -15 times a +3 is going to get a -45. So
Gotta quit bumping my button on my pen.
when we check, -45 comes in place of z, and a -45 divided by 3 is a -15. One negative results in a negative with division, so that works.
All right, now we're going to move on to the next level of equations, solving two-step equations. Okay, they're called two-step because two things are happening to your variable. And here's how we're going to attack it. Step 1 is we're going to undo any of the addition or subtraction first. Step 2 is undo the multiplication or division second. And then you're going to make sure you show all your work and check your solution. So the way I kind of remember how to do the order of these is I think of getting a Christmas present or birthday present. Mom or dad buy you a present, they put it into a box, and then they wrap it up with wrapping paper. When you go to open it, you take off the wrapping paper and then you open up the box. You do it in the opposite order you normally would. When we're solving an equation, you're doing the same thing. Normally we would multiply first and then add, but we want to go backwards, so we're going to take care of the adding and then our multiplication.
Okay, so we have an adding 3 on the left side of the equation. To undo addition, we subtract 3 from both sides. We're going to simplify. +3 minus 3 cancels each other out. We're left with 2x. The 2x has to come down on the left side. And we're going to simplify the 11 minus 3 to make it 8. 2 times x equals 8. So we're going to divide both sides by 2. Dividing both sides by 2, x is going to give us 4. So we're replacing 4 back into the equation. 2 times 4 is going to give us 8. 8 plus 3 is going to give us 11. That one checks out.
All right, next one. So again, draw that line down, and it helps remind you that we need to see every step showing on both sides of that line. It reminds you to show it twice, once on either side. Again, start with the adding or subtracting. They subtracted 7, so I'm going to do the opposite of adding 7 to both sides. -7 and +7 are going to cancel each other out and turn to 0, and we're left with w over 3. 13 plus 7 is 20, and now I go back to my variable. What are they doing to w? Well, they are dividing by 3, so I want to do the opposite, which is multiplying times 3. 3 divided by 3 becomes a 1, or just 1w, which is what we want. 20 times 3 is 60. To do our check, we plug it back in. So 60 divided by 3 minus 7. 60 divided by 3 is 20, minus 7 is 13.
Check. Moving on. Woo, with the negatives.
I think these are our last couple.
All right, we have m divided by -5 plus 6 is what we need to attack. So we're going to subtract 6 from the right. On the left, we're going to show, instead of subtracting 6, we're going to show adding a negative, just like Mr. McKenzie told us to do.
Since that number up top was a negative.
And now we're going to simplify. That gives us a -21 on the left and an m divided by -5 on the right. To undo our division, we need to multiply both sides by a -5. Do not leave a negative behind. So m is going to end up by itself on the right. A -21 times 5 is going to get a positive 105. This is where the check becomes really important to make sure our negatives are okay. 105 divided by 5 is going to give us -21. -21 plus 6, different signs subtract. That's how we get the -15.
All right.
You kind of got your writing on the right-hand side. Let's see if you can cram.
I can fit it in there. All right. Draw that line down. Again, focus on the adding or subtracting first. They subtracted 8, so I want to add 8 to both sides. Notice when we see that basic subtraction, we're not changing it to adding the opposite in the problem because we're just getting rid of it by doing the opposite, so we can leave it as subtracting because we want to add. But those two cancel out, and we're left with -4x. -12 plus 8 is going to give me -4. Then -4x means -4 times x, so I want to do the opposite, which is to divide, but make sure you're taking both the number and the sign when you're doing your multiplying or dividing. We want to cancel out the 4's, but we also want to cancel out the negatives. So those two turn into a 1, or just x. -4 divided by -4 is 1. To do our check, plug it back in place of x in the original equation. -4 times 1 is -4, minus 8. -4 minus 8 is the same as -4 plus -8, which gives me -12. That's what we wanted, so we know we've done it correctly.
Good. See you later.